Let's have a look at question 2 in this video. So what do we have here? We have data on the number of hours worked per week and the highest education level. Okay, so we have either full-time work or part-time work over here. And then we have three types of education: high school, bachelor, and graduate. And two types of work: part-time, full-time. So we have everything here in the table. We can see that there's something with observed, so with the actual counted observations and the expected count. So this should ring a bell. That has to do something with chi-square, because that's the test that deals with observations and expectations. Now consider the table. Which chi-square test is performed, what are the hypotheses, what's the distribution, the degrees of freedom, and the conclusion. So what do we have here? We have a chi-square distribution. That's the first thing that we noticed. Now the chi-square distribution, the chi-square test, what kind of test is here? Since we have two variables, two categorical variables, work and the degree of education, meaning we're testing a relationship between these two categorical variables. We're testing whether they are independent of each other or not. So we're having a chi-square test on independence. And now the hypotheses are that there's no relationship between the work and the education, so between the work hours and education level. I'm just writing it a bit shorter. And the alternative should be the opposite, that there is an actual relationship between these two variables. So there is a relationship between these two variables. And how do we calculate that? Well, we're going to compare observed values with expected values. We have already here the observed values. We already know how many people work part-time with a high school diploma, with a bachelor diploma, with a graduate diploma. And we also have the same data for those people who work full-time. The question is, how are we going to calculate the expected values? Well, first of all, we have to understand that expectations in statistics is always dealing with probabilities. So the expectation has to do something with probabilities. Now the question is this: what is the probability of having a high school person with a part-time job? Well, we have a look over here that we have in total 217 people that work part-time out of 942 people that we survey. So 217 out of 942 is going to give us 23% we expect to be people that work part-time. So proportion of people that work part-time. Now with this in mind, we can calculate what is the proportion of high school kids working part-time, what's the proportion of bachelor students working part-time, what is the proportion of graduate students working part-time. So let's do it right next to the table, because we need a bit of math here. So this is going to be cell 1, 2, 3, 4 over here, 5 and 6. So for the cells 1, 2 and 3, we're dealing with part-time workers, meaning we expect to have 23% out of each group working part-time. So we have in total 546 kids with high school diplomas, and we expect of them 23% to work part-time, meaning that 0.23 times 546 people with high school diploma are gonna be, in expectation, 125.8 people that work part-time and have a high school diploma. So this one would be 125.8. Now the same logic we're gonna solve for the other cells. So let's make some space over here and do it. Now in the second group we have bachelor students. In total there's 258 of them. So the actual observations of total students with bachelor degree, 258. Out of them we expect to have 23% working part-time. So 23% out of the total 258 students with a bachelor degree, we expect to have 59.3 students that have bachelor degree and work part-time. And the same logic goes for the last cell. In the last cell we have over here graduate students, which are in total 138 graduate students. Out of those we expect 23 to work part-time. So 0.23 out of 138 graduate students are gonna give us in expectation 31.7 graduate students that work part-time, and that would be, so that would be the third cell, 31.7, and over here we calculated 59.3. With the same logic, we're gonna solve for the other three cells. So what do we need now? We need the proportion of people who are gonna work full-time. Well, the proportion of people who are gonna work full-time is gonna be the 725 that we observe out of the total of 942. So 725 out of 942 is equal to 0.77, or 77% are the proportion that work full-time out of the total people that we research full-time. And it makes sense because the 77% with the 23% from here makes up to the 100%, and that's what should happen. So 0.77, and now with the same reasoning, we're gonna calculate for the cells 4, 5, and 6. So in cell 4, we're looking at the high school kids, and we know that there should be, we expect to be 77% from this group of high school kids that work full-time. So out of 546 in total, we expect to have 0.77 times 546. We expect to have 420.4 students with a high school diploma working full-time. So this expectation should be 420.4. Now we go to the next cell, to the bachelor students. What do we see here? Out of 258 total students with bachelor degree, we expect to have 77% working full-time. So we would have 0.77 times 258. We expect to have 198.7 students with a bachelor degree working full-time. So 198.7. And over here, the last cell, what do we have? We have students that are graduates. So we expect to have, out of 138 students that are graduates, 77% working full-time. So 0.77 times 138 is gonna equal 106.3. So this is what we expect in this cell over here. And now we did all this math because the chi-square test takes these values into account. So with a chi-square test, we're going to take the sum of the squared differences between them. We're going to take the sum of the squared differences between the observed values, the expected values for every cell relative to the expected value. Now, this is what we're gonna do, but because we have already the software who gave us the actual significance level, we can shortcut it. We can have a look at the significance level, which is 0.017. So because it's 0.017, it seems to be less than the significance level alpha, less than 0.05. So that's gonna give us a significant difference. So sorry, a significant relationship. The relationship between the working hours and the education level is significant, meaning that whether you have high school, bachelor, or graduate degree is gonna matter whether you work part-time, full-time. And intuitively it makes sense because depending on the education level, the skill level is gonna differ, and the skill level determines how much value you provide. How much value you provide determines how much money you can make and how much you can work overall. So the intuition is there, it makes sense, and the statistics is proving it. One last thing before we finish, the degrees of freedom. That's something that I forgot to do, so let's just do that over here real quick. The degrees of freedom for a chi-square test on independence is the number of rows minus 1 times the number of columns minus 1. We have how many rows? We have 1, 2 rows, the two types of work, and 1, 2, 3 columns for the types of education. So we have 2 minus 1 times 3 minus 1, which is equal to 1 times 2, and that's 2 degrees of freedom. Hope this makes sense, and we are done.